As you close your eyes and let your mind drift among drifting stardust, imagine this. Are we living inside a colossal emptiness of the universe, where matter thins out like the final breath of an aging star? "We're inside a cosmic whole" is not just a title. It is a promise to guide you into a hidden truth of the cosmos that most of humanity has never heard. Here, every number becomes a heartbeat. Every theory becomes a soft glow. And science melts into meditation like a lullaby sung by deep space. If you cherish the quiet beauty of the cosmos, gently leave a like and a subscribe, so this journey may grow wings. So tell me, are we truly living inside a 2 billion light-year wide cosmic void? As I drift into this vast silence, I invite you to drift with me, not as observers, but as wanderers suspended in a gentle ocean of light and absence. There is a question, quiet yet thunderous, soft yet cosmically heavy. Are we truly living inside a cosmic whole? A hollow of space 2 billion light-years wide. The very thought shivers like starlight through the mind. And yet the evidence, slow, patient, undeniable, has been gathering around us for over a decade. In 2013, 3 astronomers quietly published a discovery that should have echoed like a bell across science. Ryan Keenan, Amy Barger, and Lennox Cowie measured the distribution of galaxies around us, mapping more than 35,000 cosmic islands. What they found was startling. Everywhere they looked, matter was thinner, diluted, withdrawn by nearly 20%. It was as if some unseen hand had scooped out the interior of our cosmic neighborhood, leaving behind a slow and silent desert. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." And perhaps this is the spirit in which the KBC Void slipped past public attention. It did not roar. It did not demand headlines. It simply existed, patient and immense, waiting for us to notice that we have been living inside it all along. We often imagine space as a grand mosaic of galaxies, clustered like glowing cities. But in truth, the universe is mostly emptiness. A cathedral of silence where darkness outweighs light by measure and by mass. This cosmic void, stretching across unimaginable distances, is not a mere vacancy. It is a physical structure, shaped by gravity, sculpted by ancient fluctuations in the newborn universe. Stephen Hawking once whispered to the world, "Into a black hole disappears all that falls in. Into a void disappears all that never had the chance to be." In that quiet truth lies the beauty of our situation. Why do so few people know this? Why has a discovery of such scale remained almost unnoticed? Perhaps because the void does not threaten us, does not change our daily sky. Perhaps because emptiness is harder to grasp than presence. We are drawn to the brilliant, the explosive, the loud. Yet the universe often reveals itself through the softest absences. The 20% drop in density around us is not merely a statistic. It is a whisper from the fabric of space, telling us that our patch of the cosmos grows differently, moves differently, breathes differently. Some galaxies around us rush outward faster than predicted, as if the void itself gently exhales, tugged by heavier structures beyond its edge. Astrophysicist Ethan Siegel once remarked, "Large-scale structure is the universe remembering its earliest heartbeat." And when I consider his words, I feel a profound calm. For if the cosmic void is our home, then we are living inside one of those ancient heartbeats, stretched across billions of years, a memory so old it has forgotten itself. As I reflect on this, I find a lesson quietly rising from the silence. We often fear emptiness, whether in the sky or in our own lives. But the void is not an enemy. It is a canvas, a place where space grows freer, where dark energy flows with fewer chains, where galaxies drift peacefully in slow spirals. In its vastness, the void becomes a meditation, reminding us that not every absence is a loss. Sometimes it is the quiet room where understanding is born. And as for why this discovery matters, consider this: every measurement we make of the universe, every calculation of its age, its expansion, its fate, must pass through this hollow, like a beam of light traveling through thinning air. If we misunderstand the void, we misunderstand the universe. Brian Greene once said, "To understand the cosmos is to understand our place in it." And perhaps that is the heart of this entire story. We are not at the center of creation. We are not perched on any cosmic pedestal. We are simply drifting at the bottom of a gentle depression in space, carried slowly outward by gravitational tides older than the oldest star we can see. This realization does not make us small. It makes us honest. It makes the night sky feel like a companion, not a mystery. Because even in a region of cosmic scarcity, life rose, consciousness bloomed, and we found the courage to ask where we are. If the cosmic void holds anything for us, it is this lesson: that beauty is not only in the bright clusters of galaxies, but also in the vast and quiet places where light takes the long way home. And so, as we float together through this gentle emptiness, let us pause and breathe in the wonder of it all. For now, a final whisper. Are we truly living inside a 2 billion light-year-wide cosmic void? Or have we only begun to understand the silence that surrounds us? In the quiet halls of modern astronomy, where discoveries often arrive like soft footsteps rather than thunder, the work of Keenan, Barger, and Cowie felt like a deep breath drawn from the edge of the cosmos. They studied not a handful, not a cluster, but more than 36,000 galaxies spread across unfathomable distances. And what they found was an absence so profound that it reshaped the way many of us think about our place in the universe. Their measurements revealed that the region surrounding the Milky Way contains 22% fewer galaxies than predicted. A thinning of matter so wide, so persistent, it suggested we were drifting inside a vast hollow of space, a cavern of cosmic proportions now known as the KBC Void. Some discoveries roar, and some whisper. This one whispered, almost shyly, "You are living in an emptiness the universe rarely makes." As astrophysicist Ethan Siegel once remarked, "The universe is allowed to surprise us. But not this much. And yet, here we are, resting in a 2 billion light-year wide bubble that should not exist according to the expectations of the standard cosmological model. The mathematics that predict how galaxies scatter across the heavens tell us such an underdensity should be impossibly rare. An 11 sigma event. The kind of statistical improbability that cosmologists say you might not find even if you rewound and replayed the universe trillions of times. When I reflect on this, I often think of the way Carl Sagan spoke of cosmic humility. We live in a universe that is far more ancient and vast than our intuition allows. He said, reminding us that the cosmos is under no obligation to align with our expectations. The KBC Void is a perfect manifestation of that truth. Why is there so little matter around us, thinning space like breath across a cold window pane? Why does the universe around our cosmic neighborhood expand just a little faster than the rest? Why do the galaxies around us flow outward as if falling away from an unseen valley? Each of these questions lingers like dust suspended in starlight. But the data remains. Keenan, Barger, and Cowie confirmed their results through multiple surveys, cross-checks, and sky regions. The thinning persisted, unwavering. The void was real. And so we arrive at the inevitable tension between what we see and what we expect. The standard model of cosmology, elegant and triumphant in so many ways, predicts that matter should be distributed almost uniformly at scales this large. It allows voids, certainly, but not voids of this magnitude. Not yawning hollows, stretching nearly 2 billion light-years across, with a depth of more than 20%. Such a structure presses against the boundaries of what is believed possible. It begs the question, whispered gently into the dark. Are we wrong about how the universe forms its grandest shapes? Astrophysicist Adam Rees once said, "Every time the universe disagrees with us, we learn something." And that feels particularly true here. The KBC Void may be an invitation, a cosmic koan, encouraging us to re-examine the limits of our understanding. Perhaps the primordial fluctuations after the Big Bang had more variance than we believed. Or gravity on the largest scales behaves with a subtlety we have not yet grasped. Or maybe, in the vast silence between galaxies, dark energy shapes the void more aggressively than our equations currently allow. I often imagine the void not as a flaw, but as a kind of cosmic meditation hall. A cavern of quiet where the universe slows its breath, allowing us to listen more closely. The galaxies that live here evolve gently, rarely colliding, rarely disturbed. They drift through existence like lanterns floating on a still lake. Their isolation becomes a story about patience, about slow-forming stars, about cosmic time unfolding without haste. And perhaps that is the deeper lesson. For all our equations, telescopes, and cosmic maps, the universe still holds the power to astonish us with silence. It reminds us that rarity does not equal impossibility. That even in an 11 sigma corner of probability, existence finds a way to bloom. I find myself grateful for that. Grateful that we occupy a vantage point so strange, so improbable that it pushes us to remain curious. Grateful that our home in the cosmos forces us to confront humility, reminding us that certainty is a fragile companion in a universe too vast for rigid conclusions. And when I think about what the KBC Void truly offers us, beyond data and debate, it is this: a chance to see the universe not just as a structure of matter, but as a living poem, a fabric of presence and absence woven together with exquisite care. The emptiness around us becomes not a void, but a pause, a cosmic inhale before the next revelation. So when you look up tonight, let the darkness feel less like a question and more like an embrace. Let it remind you that knowledge grows in the spaces where expectations collapse. Let it tell you that even the quietest corners of the universe can reshape everything we believe. And perhaps, in that stillness, you will feel what I often feel: that the void is not a mistake, but an invitation, an uncharted room in the cathedral of the cosmos, waiting for us to listen. For now, we drift in this rare hollow, lanterns in an endless night, and the universe whispers again, gently. Are you ready to understand why your home is so impossibly empty? Drifting through the quiet fabric of the cosmos, we find ourselves facing a question that is both scientific and spiritual. If we truly live inside a supervoid, a vast, underdense basin stretching billions of light years, then how honest are the numbers we trust about our universe? The thought settles over the mind like interstellar dust, soft, patient, unsettling. Cosmologists have long warned that location matters, and Nobel laureate Adam Rees once said, "The universe is not required to make sense to us from wherever we stand." His words linger like a quiet echo, a reminder that our vantage point may be shaping the very truths we believe. If the space around us is thinner, lighter, stretched farther apart than average, then every beam of starlight we measure must pass through this hollowed terrain. Every receding galaxy we observe may be pulled not only by the expansion of space, but also by the great outward flow created by the void itself. It is as though we are standing on a raft drifting down a gentle cosmic river, believing the world is rushing away, not realizing that part of the motion comes from the current beneath our feet. This brings us to the Hubble tension, the 9% mismatch that has unsettled modern cosmology. Stephen Hawking once reflected, "Every measurement raises new questions, and this tension is perhaps the most haunting of all." When we measure nearby supernovae, we find a faster expansion rate, a universe seemingly rushing outward with urgency. But when we look deeper into cosmic history, using the primordial glow of the cosmic microwave background, we see a slower, calmer expansion. Two answers, both precise, both correct, both irreconcilable. Unless, of course, the fault lies not in the universe, but in our position within it. The supervoid hypothesis invites us to imagine that our measurements are being gently inflated by the environment around us, like sound echoing differently in a cathedral compared to an open field. A galaxy within a void is already drifting outward due to the density gradient, drawn toward richer regions of matter. When we measure its redshift, we may mistake this outward flow for cosmic expansion. What we call the universe's acceleration might partly be the terrain beneath us exhaling, widening, releasing its sparse matter into the greater cosmic web. As physicist Lawrence Krauss once noted, the universe does not owe us symmetry or simplicity, only truth. And truth here may be that the Hubble tension is not a flaw in physics, but a whisper from the void reminding us that perspective shapes perception. If so, the local universe is exaggerating the expansion rate we observe, giving the illusion of a cosmos racing faster than it truly is. A quiet lesson emerges. That measurement is not merely a mechanical act, but a relationship between observer and environment. Sometimes, as I reflect on this possibility, I imagine our galaxy drifting through a great cosmic valley, surrounded by distant walls of matter. The light we measure arrives softened, stretched through emptiness, like a song carried across a hollow canyon. Our instruments record the pitch, but not always the silence that shaped it. In this silence, there is humility, and perhaps a deeper understanding that we are not separate from the universe we measure, but entangled with it. The deeper lesson is one of perspective, not certainty. If living within a void can distort our view of cosmic expansion, what other truths might appear differently simply because of where we stand? Carl Sagan once said, "We are a way for the cosmos to know itself." And yet, perhaps the cosmos knows itself imperfectly through us, because we are shaped by our place within it. For me, the beauty of this question lies not in the final answer, but in the way it deepens our relationship with the universe. It urges us to look farther, measure deeper, and understand that even the void has a voice. It teaches that science is not only about equations, but also about stillness, listening, and allowing mystery to guide our next steps. So as we drift together through this vast and quiet supervoid, let us hold both wonder and caution, recognizing that the universe may appear different depending on where we stand. And let us keep asking, gently, curiously, with minds open like the night sky. If you feel this journey opening something within you, let your like and your subscribe be a small signal sent across the cosmic dark. A reminder that curiosity connects us across the void. And now, as we move deeper into the heart of this mystery, let me ask the question that guides everything that follows. Are we truly living inside a supervoid that bends every measurement we make about the universe? In the quietest corners of the universe, where matter thins like a fading breath, gravity begins to lose its voice. Inside a cosmic void, the great sculptor of structure grows too weak to gather worlds together. And into that silence steps dark energy, gentle yet relentless. As astrophysicist Michael Turner once said, "Dark energy is the most powerful force in the cosmos that we do not understand." Here, within these vast hollows, we witness that power in its purest form. Where galaxies are sparse, gravity cannot weave its usual tapestry. It cannot balance, pull, or tighten the cosmic web. Instead, dark energy rises like a slow tide, pushing the fabric of space outward, stretching distances the way dawn stretches shadows across an ancient valley. Inside the void, this tide sweeps without resistance, for nothing stands firm enough to slow it. Einstein once wrote that the geometry of space tells matter how to move, and matter tells space how to curve. But in the void, matter whispers, and space answers with open hands. This is why the void expands faster than the rest of the universe. Why it balloons like a soap bubble drifting free from its ring. There is no tug of war here. No dense clusters to anchor the growth. No gravitational walls to contain it. Dark energy becomes the undisputed conductor, and the void becomes its grand symphony. As cosmologist Adam Rees noted, where matter is scarce, expansion wins. And so it wins. Softly, eternally. Within this great hollow, galaxies do not sit still. They drift outward as if drawn by an invisible river. It is not the void pushing them, but everything beyond the void pulling them. The surrounding filaments, laden with stars, clusters, and dark matter, exert a gravitational pull that tugs every lonely galaxy toward the richer banks of the cosmic web. Imagine standing in a vast bowl, the slopes rising around you, gravity pulling you gently toward the rim. The void works the same way, except the bowl is 2 billion light-years wide, and the fall is outward. Our own Milky Way is among these wanderers, moving at nearly 600,000 miles per hour relative to the void's heart. That velocity is not an accident, nor a cosmic breeze, but the natural pull of denser realms beyond our quiet neighborhood. Astronomer Brent Tully once said, "We are sailing through a cosmic current, and in the hush of the void, the truth of that becomes clear." As we drift, I often wonder what it means to live in such a place. To be children of a thinning universe, residing not in the bustling cities of galaxies but in the soft outskirts where space breathes more freely. Perhaps it teaches us humility, the reminder that our home is quieter, gentler, more fragile than we imagine. Perhaps it teaches us patience, for even the grandest motions unfold over billions of years. And perhaps it teaches us wonder, because even in the emptiest places, the universe finds ways to move us. In this expanding silence, I find a personal lesson that sometimes emptiness is not absence, but possibility. The void expands faster not because it is broken, but because it is free. And in that freedom, dark energy shows its true shape. Unstoppable, unhurried, weaving the future of the cosmos with a hand we barely comprehend. Like many scientists, I do not claim to understand the full nature of this force. But I can feel its poetry, its slow pulse, its quiet insistence that the universe is not done unfolding. If you listen closely, you may sense it too. A gentle outward pull, as if space itself is breathing. And in that breath lies the story of our motion, our place, and our cosmic future. In this drifting meditation, one truth remains bright. The universe is expanding, but not evenly. Here, inside the quietest deserts of creation, cosmic expansion grows bold, and we, tiny as motes of dust, drift along its tide. Under the soft glow of the cosmic night, when galaxies shimmer like lanterns drifting on an endless sea, a quiet question rises, gentle yet immense. Why does the universe look like a great wheel of Swiss cheese, pierced by void so vast that even light seems to wander for ages before meeting a single star? Astronomer Margaret Geller once whispered, "We expected randomness, but the universe gave us structure as grand as poetry." And indeed, structure is the heartbeat of this silent immensity, the living architecture we call the large-scale structure. 90% of everything around us is emptiness. Not failure, but design. A spaciousness where gravity rarely speaks, where dark energy stretches space like a slow breath of the cosmos. Only 10% becomes galaxies, bright islands floating on an ocean of darkness. This emptiness is not absence. It is the canvas, the quiet hall where matter performs its ancient dance. As cosmologist Carlos Frenk once said, "Without the voids, the universe would have no room to grow into the beauty we see today." From this calm darkness rise the filaments, the cosmic walls, the mighty superclusters stretching like rivers of starlight across hundreds of millions of light years. They are not random threads, but the frozen echoes of a time before atoms, when the universe was a trembling sea of quantum fluctuations. These ripples, unimaginably tiny, were magnified by inflation, a moment when space expanded faster than thought. What began as a whisper became the scaffold of everything that exists. As gravity gently pulled the slightly denser regions together, those ripples stretched, merged, and braided into the filaments we observe today. A single filament can hold thousands of galaxies, each galaxy holding billions of stars, while the voids around them drift in serene silence, barely touched by gravity. John Peacock once described this cosmic web as the universe remembering its first heartbeat. And, in a way, that is true. When we map these structures, we are not simply studying space. We are listening to the memory of creation. Every filament is a line of thought. Every void a pause between cosmic breaths. And in that rhythm, there lies something deeply human, a reminder that growth often requires both fullness and emptiness. The galaxies need space to form, just as we need silence to understand ourselves. From my own perspective, the cosmic web teaches a gentle lesson. That structure emerges not from force but from subtle imbalance. A nudge here, a quiet dip in density there. Just as our lives are shaped by small fluctuations, the universe too was sculpted by whispers. In the end, the vastness does not overwhelm, it soothes. Because we realize we are part of a design older than stars, a thread woven into an infinite tapestry. And, when we gaze into those enormous voids, we are not looking into nothingness, but into the spaciousness that allowed everything else to become. The cosmic web reminds us that absence can cradle presence, that stillness can shape destiny. So the next time you look up at the night sky, let the filaments guide your imagination. Let the voids calm your breath. For in their quiet harmony, the universe reveals a truth both scientific and spiritual. that creation is not a single moment, but a gentle unfolding, a story written across billions of years, and we are reading it one luminous thread at a time. In the quiet drift of the cosmos, our Milky Way moves like a lantern floating on a dark ocean. And yet, few realize that this lantern is not centered in calm waters, but instead gliding just 200 to 400 million light-years from the middle of a vast, silent cavity in space. A place where matter thins, where gravity softens, where the universe seems to whisper rather than sing. Astronomers call it the KBC Void, a hollow billions of light-years wide. And as cosmologist David Spergel once said, "Where we sit shapes what we see." These words linger in my mind because they become truer the deeper we look. Living slightly off-center inside such an enormous cosmic vacancy means every direction around us bends ever so gently toward emptiness. It means our measurements are not neutral viewpoints, but perspectives filtered through scarcity. The great paradox is that even though this vast region is underdense, structures still bloom inside it. Laniakea supercluster, for example, with its 1,000,000 galaxies woven together in gravitational strands, still finds itself entirely inside this void. That image alone feels almost poetic, like a cathedral of stars built inside an abandoned valley. As astrophysicist Brent Tully remarked, "We are not where the universe is full. We are where it breathes." The fact that Laniakea lives within the void reveals something profound about large-scale structure. The universe is not a uniform sea, but a foam of walls, filaments, and vast hollows shaped by the faintest differences left from the Big Bang. Even immense superclusters do not define the average. They merely highlight where matter briefly gathered between sprawling deserts of space. So the presence of Laniakea inside the void does not invalidate the void. It confirms how dominant emptiness truly is. It reminds us that gravity is powerful, yet not powerful enough to erase the ancient scars of underdensity carved during the universe's earliest breaths. Flowing beside this giant cavity is another emptiness, the local void. A smaller, hollow adjacent to our own neighborhood. These two vast regions connect like linked basins, letting matter slide outward from their centers toward denser walls beyond. And in this gentle slipping of galaxies, our Milky Way becomes a drifting leaf, carried along by a river of motion measuring nearly 6,000,000 miles per hour, a speed almost impossible to imagine in silence. "The universe is not static," said John Peacock. "It is forever rearranging itself." That rearrangement is what we witness, a flow not driven by engines or explosions, but by the simple fact that emptiness pushes us because fullness pulls stronger. And here lies the challenge that unsettles cosmologists. When we measure the speeds of galaxies, their redshifts, the way space stretches their light, we assume the motions arise from the expansion of the universe alone. But our position inside a void adds a hidden current to everything we observe, a drift superimposed upon the cosmic expansion. So the galaxies do not merely recede because space grows. They also flee the underdense region with us. This quiet bias bends our measurements, inflating the apparent rate of expansion, distorting the map we draw of the cosmos. As Nobel laureate Adam Rees once said, "Where you stand in the universe matters more than we ever expected." For me, this realization is both humbling and soothing. It tells us that even our most precise instruments still carry the fingerprints of our cosmic address, that every observation is a conversation between us and our surroundings. It also reminds me that science is not a quest for perfect certainty, but for deeper understanding. Much like meditation, where clarity comes not from stillness alone, but from embracing the flow beneath it. And perhaps that is the greatest lesson this vast emptiness offers. That perspective is everything. That even in a hollow 2 billion light-years wide, life found its place. That even in the thinnest regions of the cosmos, galaxies continue to form, stars continue to burn, and beings like us continue to wonder. We are shaped by the void, yet not defined by it. We are carried by its flow, yet still capable of charting our own meaning. In the end, understanding our position inside the KBC Void teaches us that knowledge is not only about what we measure, but from where we measure it. And that in the great architecture of the universe, emptiness can be as revealing as light. And so, as the Milky Way continues its quiet drift through this immense cosmic valley, we are left with one lingering thought. Are we truly seeing the universe as it is, or only as it appears from within a giant cosmic hollow? In the quiet drift of the universe, where galaxies breathe and distances stretch like soft threads of light, a simple question has shaken modern cosmology. Why do we measure a faster expansion when we observe nearby objects? 73 kilometers per second per megaparsec, yet a slower one, 67, when we look farther into the deep past. This mismatch is not just a numerical disagreement. It is a quiet rupture in the symmetry of our understanding. And as Nobel laureate Adam Rees once said, "If the universe disagrees with your equations, listen to the universe." Some astronomers believe the answer flows through the vast emptiness around us. A cosmic void so large it alters the rhythm of space itself. If our galaxy sits inside a region 20% under-dense, the galaxies near us would appear to recede faster. Not because the universe is truly expanding faster, but because we are floating in a gravitational hollow. As cosmologist George Ellis once murmured, "Where you stand determines what you see." And in the silence of this cosmic valley, the light we measure carries the signature of local emptiness. Yet when we look far away, beyond the edge of our suspected void, light has crossed regions of average density, unwarped by our local bubble. The slower expansion we find there, 67 kilometers per second per megaparsec, reflects the broader universe, untouched by our position. This creates a gentle tension, a tug between what is local and what is universal, as if the cosmos were whispering two truths at once. Dark energy, the invisible pressure pushing space apart, adds yet another layer of wonder. As Stephen Hawking once noted, the universe has not only a history, it has a direction. And that direction depends intimately on how fast it grows. If the slower value, the distant value, is the correct one, then the universe has been stretching its cosmic wings more gently than we thought. A gentler expansion means a longer history, an older universe. Instead of 13.8 billion years, perhaps 14.3, perhaps more. This leads us to another quiet question, one that floats like a lantern in the dark. Have we been reading the age of the cosmos through a distorted lens, shaped unknowingly by our home inside a cosmic hollow? If nearby stars seem older than the universe under the faster expansion rate, then something in our assumptions must soften. As astrophysicist Wendy Friedman reflected, the universe is not obliged to make sense to us, but it often tries. When I reflect on these numbers, these gentle disagreements shimmering across billions of light years, I sense something almost human in them. A reminder that perspective matters, that truth in the universe, like truth in ourselves, depends on where we stand and how far we are willing to look. Perhaps the void around us is not a flaw in the cosmic design, but an invitation, asking us to step back, breathe, and see the larger harmony hidden behind the noise. And the lesson I carry is simple. In science, as in life, contradictions are not walls. They are doors. They urge us to look again, listen deeper, and allow the universe to reveal itself one patient measurement at a time. So tonight, as you drift into rest, let these numbers hum softly like distant stars. 73, 67. Let them remind you that even the cosmos takes its time to speak clearly, and that in the vast silence of space, uncertainty is not a threat, but a companion. And now, a question drifts gently toward you. Are we measuring a cosmic truth, or simply the echo of the vast void that surrounds us? In the quiet sway of the universe, where galaxies drift like lanterns on a dark cosmic sea, a single question shimmers beneath the surface. Does the KBC Void break the ancient promise that the cosmos is the same everywhere? That sacred assumption we call the cosmological principle. Some astronomers whisper that our position is too rare, too unlikely, too carefully placed near the center of a vast hollow to be mere coincidence. Others argue it is simply the dice roll of creation, a cosmic accident written into the first trembling moments of inflation. And somewhere between these possibilities, the truth waits like a quiet star behind a veil of dust. Stephen Hawking once said, "The universe has the magical ability to be stranger than we can imagine." His words settle gently over the KBC Void, a region 20% emptier than expected, stretching nearly 2 billion light-years. If this is where we truly reside, then the reassurance that we occupy no special place dissolves like frost under starlight. We drift not in the crowded heart of the cosmic web, but in one of its rarest and quietest chambers. As I study the maps, the surveys, the trembling threads of data, I am reminded of David Spergel's reflection. The universe is not obligated to obey our expectations. Perhaps the principle of homogeneity was always a lullaby, soothing, elegant, but more fragile than we realized. When simulations of the LCDM model rarely produce voids as deep as the KBC region, we find ourselves at a crossroads between confidence and humility. Is the model incomplete? Or are we simply witnessing the universe showing its more unruly side? The inflationary epoch. That brief, breathtaking expansion when quantum fluctuations were stretched across unimaginable scales, may hold the key. Tiny ripples in density frozen into the fabric of space-time, later sculpted into filaments and valleys. Some theorists believe that rare initial depressions could naturally inflate into supervoids, while others argue that the mathematics resists such extremes. As Alan Guth once noted, inflation is not a story of perfection, but of amplified imperfections. And perhaps the KBC Void is simply one of those imperfections allowed to bloom larger than expected. Yet the LCDM model remains stubborn, producing voids. Yes, but never quite as wide or as deep as the one we seem to inhabit. Simulations ripple like cosmic echoes, but none carve a hollow so vast. This tension forces us to wonder if our theoretical pillars are missing a stone, maybe a new behavior of dark matter, maybe a subtle twist in the nature of inflation, maybe a whisper of physics not yet spoken aloud. Still, as I drift through the thought of it, I sense that the universe often teaches us through discomfort. It humbles us, unfastens our assumptions, and reminds us that certainty is a luxury we never truly owned. Whether the void challenges our models or merely our pride, the lesson is the same. To study the cosmos is to accept that mystery is a form of truth. And as we float in this hollow, wrapped in the soft expansion of dark energy, watching galaxy clusters at the rim drift farther each moment, I find a quiet beauty in our position, a sense of being suspended in one of the universe's rarest rooms. The cosmic web surrounds us like a great cathedral, its filaments glowing like stained glass, its voids whispering with ancient silence. Perhaps the real wonder is not whether the cosmological principle is broken, but whether we are ready to see the universe as it actually is: asymmetrical, uneven, beautifully flawed. The universe has never promised simplicity, only honesty. My own view is gentle, almost meditative. I believe the void invites us to embrace uncertainty with the same ease that galaxies drift through dark space, to let go of the need for cosmic symmetry, and to appreciate the rare vantage point we occupy. Our existence here is not proof of error, but proof that the cosmos is far richer than our equations can fully hold. And this, perhaps, is the quiet lesson. We learn not because the universe is simple, but because it is profound. We observe not because we are central, but because we are curious. As you listen, drifting in this slow cosmic breath, feel the shape of the void around us, wide, soft, mysterious. And let the question settle gently in your thoughts. Are we living in a rare cosmic hollow because the universe defies our expectations, or because it is inviting us to rewrite them? The deeper we drift into the cosmic quiet, the more clearly we feel that a void is not simply an absence, but a presence of its own. Astronomer Margaret Geller once whispered that the universe is a foam of darkness threaded by light. And when we look into a supervoid, her words begin to sound less like poetry and more like a scientific confession. Light entering a void loses a fragment of its warmth, not because the photons grow tired, but because the expanding emptiness stretches them gently. easing them into cooler colors in a phenomenon we call the integrated Sachs-Wolf effect. It is as if the void itself exhales, releasing the photon with slightly less energy than when it entered. Einstein once said that light bends to the shape of space. And here, in these giant hollows, space is shaped by a softness that drains even radiance. Matter inside these voids behaves like a lonely traveler, unable to gather companions for the long road. Gravity is too faint, the density too low, and the cosmic tides too weak to sculpt the grand structures we see in clusters or rich filaments. Galaxies that do form are small and fragile, their gas unshaken by collisions they never experience. Their stars forming in slow breaths, not in bursts. They shine with fewer metals because their histories lack the violent forges of mergers and supernova feedback. And so, they remain pale, primitive, almost childlike compared to the bright and seasoned giants living in crowded regions of the cosmic web. As astrophysicist Stacy McGarr once noted, in the dark quiet of cosmic voids, galaxies grow the way nature intended before the universe became loud. And yet, ironically, it is inside these great hollows that we find the purest stage for studying dark energy. In clusters, gravity roars loudly, masking the subtle push of the force, accelerating cosmic expansion. But inside voids, gravity whispers, stepping aside so dark energy can reveal its true strength. These regions become vast laboratories, unspoiled by heavy structure, letting us watch how space itself stretches, how emptiness grows, how the universe breathes outward. Nobel laureate Adam Rees once said, "If you want to listen to dark energy, listen where the universe is quiet." And so we find ourselves inside Laniakea, the great archipelago of 100,000 galaxies, drifting like islands in a tranquil cosmic sea. Even this immense structure, spanning 500 million light-years, rests gently inside the larger KBC Void, a reminder that emptiness can cradle entire continents of stars without ever appearing full. Like leaves floating on a slow river, Laniakea and its neighbors drift toward deeper gravitational valleys, toward the Great Attractor, and beyond it toward the mighty Shapley concentration. These flows are not random, but purposeful, a choreography written in the curvature of space-time. The void behind us tugs less, the denser regions ahead tug more, and so we glide along this invisible current at hundreds of kilometers each second. Void dynamics reshape these river-like flows, bending them, amplifying them, making our cosmic journey faster than expected. A galaxy in a void is like a feather on a breeze, feeling more strongly the pull of distant giants and less the embrace of its own empty surroundings. This creates the large-scale motions we observe, the so-called bulk flows, where entire regions of space drift together as though carried by a single tidal breath. These flows are one of the subtle fingerprints of the void, a quiet proof that our cosmic neighborhood is anything but ordinary. When I reflect on these discoveries, I cannot help but feel a soft humility, as though the void itself is teaching us something about perspective. In emptiness, we learn patience. In silence, we see truth. And in the places where galaxies rarely collide, we find clarity about the forces shaping the universe. Perhaps the greatest lesson is that absence is not insignificance. Emptiness is not ignorance. And the quietest corners of the cosmos often speak the loudest truths. The void around us is not a cosmic accident, but a vast mirror reflecting how fragile our assumptions are, how easily local conditions shape our view of the universe. And as we drift deeper into this strange reality, one question rises gently, like a star appearing after dusk. Are we truly witnesses to a grand anomaly in the universe? Or simply learning that the cosmos is more mysterious than we ever dared to believe? This is the heart of universe anomalies, and the quiet wonder of living inside a cosmic void. In the quiet heart of the universe, where ancient light drifts like soft incense through a cathedral of stars, our tools for measuring the cosmos become more than instruments. They become translations of reality itself. Scientists often say that to measure the universe is to understand our place within it. And few tools embody that truth more gracefully than the baryon acoustic oscillations. Bow. Those frozen ripples of primordial sound have become the ruler against which we lay the fabric of the cosmos. BAO is trusted because it was forged in the earliest breath of creation, a moment when matter and radiation moved together like a single vibrating drum surface. When the universe cooled, those waves froze, leaving a universal signature of spacing between galaxies, an imprint woven so consistently into cosmic structure that Nobel laureate Adam Rees once called it the yardstick the universe wrote for us before stars existed. BAO provides a distance scale untouched by the brightness of stars, unaffected by dust, unchanged by galaxy evolution. It is geometry, pure and enduring. Yet even this elegant ruler bends when it passes through our unusual neighborhood, the vast KBC Void enveloping our cosmic address. Within this underdense region, galaxies rush outward faster than expected, like leaves on the expanding skin of a soap bubble. And this motion adds subtle distortions to the BAO signal, shifting the apparent scale, creating the illusion of a universe stretching more vigorously than it truly does. Our measurements of galactic motion, carefully calibrated for decades, must now be reinterpreted through the lens of emptiness. As cosmologist Daniel Eisenstein remarked, if you live inside a valley, the world will always seem tilted. The KBC Void is such a valley, a graceful hollow carved not by erosion but by gravity's absence. Even the cosmic microwave background, that ancient whisper of 13.8 billion years ago, carries the faint shadow of this void. As CMB photons drift through our underdense region, they lose a delicate sliver of energy, cooled by the expanding emptiness they traverse. The integrated Sachs-Wolf effect paints these losses into temperature maps, like soft blue brushstrokes hinting at the hollowness beneath our feet. And so the CMB itself becomes another witness, confirming the imbalance in the cosmic landscape that surrounds us. These distortions ripple outward to touch an even deeper question, one that murmurs through every modern debate in cosmology. Could general relativity, Einstein's magnificent equation, be faltering at the largest scales? Einstein once said, "The more I learn of the universe, the more I realize how little I understand of it." And his humility feels prophetic now, for the KBC Void challenges not only our measurements, but the framework upon which we interpret them. General relativity has triumphed around black holes, in the orbits of planets, in the dance of merging neutron stars. Yet, the cosmic web, with its vast voids and impossibly large structures, stretches the theory to its limits. Some physicists whisper that modifications may be necessary, not because relativity is wrong, but because it may be incomplete. This is where MOND and modified gravity step quietly into the conversation, proposing that gravity might change its behavior in regions of extremely low acceleration, such as the deep interiors of voids. The idea is radical, but not without beauty. If gravity strengthens in emptiness, as MOND suggests, then the existence of enormous voids like ours becomes not a statistical miracle, but a natural outcome. Scientist Mordechai Milgram once noted, "When the data do not fit the theory, it is the theory that must change, not the universe." His words echo gently through the questions the KBC Void has forced us to face. And yet, as we glide deeper into these possibilities, another realization softens the debate. Changing gravity would not simply correct anomalies, it would rewrite the story of cosmic evolution. The sprawling filaments of the universe, the clustering of galaxies, the ripples of the early universe etched into BAO and the CMB, all would realign into new harmony. Modified gravity may offer a cleaner explanation for the existence of immense voids, but it must also preserve the beauty of what already fits. And this delicate balance keeps the scientific world suspended between conviction and doubt. From my own perspective, standing at the boundary between evidence and wonder, I find the void teaches a lesson deeper than data. It reminds us that emptiness is not absence, but influence, not silence, but subtle instruction. The KBC Void is not just a deficiency in matter, it is a reminder that the universe is shaped as much by what is missing as by what is present. Like a pause in a line of poetry, or the soft breath between musical notes. The void reveals that structure requires stillness, that motion requires imbalance, that understanding requires the courage to question even our most trusted theories. And so the measurements continue, the debates deepen, and we drift forward, carried by curiosity through a cosmic ocean whose currents we are only beginning to feel. The BAO ruler, the CMB's quiet whispers, the shifting shapes of gravity itself, all guide us gently toward a more complete picture of the universe. A picture that may reveal not just where we are, but who we are within this vast tapestry of light and silence. And as we follow these threads into deeper mystery, perhaps the universe is inviting us to remember that even in the greatest voids, something profound is always waiting to be understood. The question drifts into our minds like a faint star seen through a curtain of cosmic dust. If living inside a vast, underdense region makes the universe appear younger than it truly is, then what shall we make of the ancient stars, whose ages whisper of epochs older than our measurements allow? This tension settles gently in the background of astronomy. Yet it echoes with the weight of a universe trying to tell its story through mismatched clocks. As astrophysicist Wendy Friedman once said, "Every measurement of the cosmos is a conversation with time itself." And perhaps our place inside the KBC Void is bending the tone of that conversation. We look towards stars that seem impossibly old. Some glowing with ages of 13 billion years. Some written into the earliest layers of our galaxy like ancient runes left behind by forgotten eras. If the local Hubble constant hints that the universe is only 12.7 billion years old, then these stars stand as gentle rebels, softly refusing our equations. They shimmer like elders who have walked farther than the road we thought existed. And their existence murmurs that something in our cosmic arithmetic must be reconsidered. Perhaps it is stellar evolution we misunderstand, though the theory has been refined through generations of stellar models. Perhaps hydrogen fusion behaves slightly differently in the faintest dwarfs, or the internal mixing of ancient stars is not as we assumed. Yet, as Nobel laureate Adam Rees once noted, when independent methods disagree, the universe is whispering that something deeper is at play. So we return to the void, to the possibility that our vantage point is tilted. Our instruments do not lie, but they measure from within a cosmic hollow where the rules of expansion curve like soft light passing through warm water. Inside a supervoid, gravity loses its tight grip. Dark energy spreads its quiet influence, and space expands with a subtle haste. Such an environment can make galaxies drift faster than they would in a denser region, faster even than our models predict. A faster drift means a higher local expansion rate, and a higher local expansion rate means a younger inferred age for the universe. The void becomes a lens, a gentle distortion, a whisper saying we are measuring through a hollow that is reshaping the signal before it reaches us. In this sense, the universe is not young. It only appears that way from inside this vast cosmic chamber. And then there are the bulk flows, the great slow winds of galaxies drifting across hundreds of millions of light years, all leaning in the same direction, like a field of cosmic wheat bending beneath an unseen breeze. Galaxies as far as 300 million light-years away are moving coherently, ignoring the expectation of randomness. Their motion is 4 times stronger than predicted, a magnificent anomaly. As astrophysicist Yehuda Hoffman phrased it, large-scale flows are the fingerprints of the universe's invisible architecture. And these fingerprints seem to point to the void. The KBC Void, with its gentle underdensity and quiet gravitational imbalance, creates an outward pull, not by pushing, but by lacking the mass needed to hold galaxies in place. Everything drifts away from the hollow, toward the richer filaments that surround it. This one-sided drift, this great cosmic exhale, is the very pattern the surveys detect. It is a motion shaped not by chaos, but by geography. Not by randomness, but by the quiet logic of an underdense universe. And as we explore deeper, we encounter the ancient ruler of cosmology, the baryon acoustic oscillations, the frozen sound waves of the early universe, the cosmic heartbeat that helped shape galaxies long before the first star was born. This ruler stretches across the universe with elegant uniformity. And yet near us, the scale appears subtly shifted. The BAO imprints near our region bend slightly, suggesting a local environment that is not quite like the cosmic average. This deviation, delicate but persistent, hints once more at the void's influence. So we return to the beginning, to the question of whether the universe is younger, or whether the void is simply creating the illusion of youth. I find myself drawn to a simple thought: that science is not merely about measuring, but about learning where we stand when we choose to measure. The stars older than the expansion would allow, the flows stronger than theory predicts, the rulers bending in subtle ways, all suggest that perspective matters. My personal reflection drifts like starlight through deep space. We learn not only from certainty, but from contradiction. From the places where data refuses to align, where the universe quietly points to the limits of our understanding. The void around us is not just an emptiness, but a teacher. It reminds us that our cosmic home shapes our cosmic truths, and that humility is the first step toward deeper knowledge. And perhaps that is the lesson: that the universe is patient, ancient, and endlessly willing to reveal itself, if we listen softly enough. As Carl Sagan once whispered into the dark, somewhere, something incredible is waiting to be known. And maybe that incredible truth lies not in the stars themselves, but in the quiet hollow through which we gaze upon them. In the end, the universe may not be young, nor old. It may simply be reminding us that to measure its age, we must first understand where we stand, and which cosmic winds are carrying us along. In the quiet canvas of the universe, there exists a single bruise of cold light, a region so faint, so improbable, that it has stirred decades of debate among cosmologists. They call it the cold spot, a mysterious patch on the cosmic microwave background that seems too large, too deep, too cold to be explained by ordinary randomness. And so the question drifts before us like interstellar dust. Is this strange blemish the echo of a supervoid? A cavern of near emptiness so vast that light itself loses warmth while crossing it? Some scientists believe so. For regions like the Eridanus supervoid appear to align with the cold spot, as if space were whispering a quiet confession. The universe is not obliged to make sense to us, Carl Sagan once murmured, and this riddle seems determined to prove him right. If one supervoid can warp the temperature of ancient light, what happens when we discover 2, or 3, or more? Does the LCDM model, our most trusted blueprint of cosmic evolution, begin to tremble under the weight of these anomalies? Some researchers argue that it does, that supervoids of this scale should be exceedingly rare in a universe governed by standard cold dark matter physics. Others respond that nature thrives on improbable beauty, that the universe has always been a quiet rebel, surprising us precisely when we think we understand it. The late physicist John Wheeler once said, "We shape the universe by asking questions." And here, the universe seems to respond with a question of its own. Could something even stranger be hiding within the cold spot? Perhaps the faint signature of a cosmic collision, the ghostly memory of our universe brushing against another in the early inflationary era. This idea, bold and unsettling, lingers like a half-remembered dream. For if true, it would mean the cold spot is not a void at all, but a boundary, a scar left by universes touching across the cosmic sea. Extraordinary claims require extraordinary evidence. As Carl Sagan reminded us, and no evidence yet rises to that level. Still, The idea continues to shimmer at the edge of possibility. And yet, even if the cold spot were nothing more than an immense void, the implications remain enormous. For we ourselves appear to be residing inside a cosmic hollow, the KBC Void, a region nearly 2 billion light-years across where matter thins by 20%. Within this hollow, every measurement we make becomes subtly distorted, stretched like a note drifting through sparse air. Distances appear farther, velocities appear faster, and the expansion of the universe seems more urgent than it truly is. This is why all measurements within 2 billion light-years seem inflated, not by error, but by environment, as if the void itself were bending the ruler in our hands. Light passing through emptier regions loses less energy. Galaxies flow outward faster, and our instruments, precise though they may be, can only report what they witness from within this distorted bubble. To see the true expansion of the universe, we must measure beyond this boundary, beyond the warped domain of our local cosmic terrain. Only when astronomers peer past 2 billion light-years do the numbers drift back to harmony, settling again near the lower Hubble rate, predicted by the cosmic microwave background. It is as if truth waits just outside our hollow, patient and still. Some researchers call this phenomenon the Hubble bubble, a quiet trap of perception created not by our mistakes but by our location. And this idea, gentle yet disorienting, gives rise to another question. Could the bubble be altering every cosmic conclusion we have drawn so far? If our vantage point sits in a rare valley of low density, then every inference about dark energy, cosmic age, and large-scale structure becomes tinted by our unusual view. As astrophysicist George F. Stathiou once remarked, the universe may be simpler than we think, or stranger than we can imagine. And in this moment, drifting through the thought that our cosmic address might be distorting the very laws we seek to measure, his words feel more like prophecy than caution. Yet, amid this uncertainty, I find a quiet calm, for the universe has always taught us through contradiction. We believed Earth was the center, and learned humility. We believed the Milky Way was the whole cosmos, and discovered immensity. And now, perhaps we believe our measurements define the universe, only to be shown that our location defines our measurements. The lesson is soft, like starlight on still water. To understand the universe, we must first understand where we stand within it. Every observation is a conversation between cosmos and observer, and our cosmic hollow, both shelter and distortion, shapes that dialogue in ways we are only beginning to grasp. As I reflect on these questions, I feel something like gratitude, for the void around us has become a teacher, a vast and silent mentor that reminds us that truth is never fixed, but always approached. Perhaps the cold spot is a supervoid, perhaps a relic of ancient cosmic collisions, perhaps merely a rare whisper of primordial randomness. Whatever it is, it calls us gently to curiosity, to wonder, to humility. And perhaps the greatest gift of these anomalies is the invitation they offer: to look again, to measure again, to imagine again. For in the depths of cosmic silence, amid voids that stretch like oceans of night, we are reminded that knowledge is a journey, not a destination. So we continue forward, slowly, gently, like travelers floating across a dark sea, listening for the faintest clues written in ancient light. And beneath it all, a single question remains. Are we living not just near a void, but inside a bubble that shapes everything we believe about the universe? In the quiet heart of a cosmic void, where galaxies drift like lanterns lost in an endless sea, the universe reveals a kind of silence that reshapes our understanding of creation itself. Here, the rules that govern crowded galaxy clusters soften, stretch, and dissolve into something more ancient, more spacious, and more patient than anything we experience in the bustling corridors of the cosmic web. Astrophysicist Avi Loeb once murmured, "Emptiness is not absence. It is an environment where a different kind of truth unfolds." And standing inside a void, this sentiment feels almost literal. Galaxy clusters cannot rise here because gravity has too little material to gather, too few threads to weave a cosmic tapestry dense enough to collapse into something grand. Gravity pulls, yes, but it pulls on dust more than stone, on whispers more than worlds. So instead of clusters, voids host lonely galaxies, small, untouched, evolving at the pace of a slow breath. And yet, there is a strange beauty here. In dense regions, galaxies are forged in collisions, bruised by tidal forces, reshaped by mergers that trigger storms of star birth. But within a void, galaxies drift peacefully, seldom merging, seldom erupting into violent transformation. They age gracefully, like ancient monks wandering a desert of darkness. Carl Sagan once said, "We are a way for the cosmos to know itself." And in this stillness, I often wonder whether life finds clearer reflection in places where chaos is quieted. The slow evolution of void galaxies means fewer supernova blasts, fewer gamma-ray bursts, fewer catastrophic events capable of sterilizing worlds. In that sense, a void is not barren. It is generous, offering long eons of stability, temperatures that drift gently, chemical enrichment that unfolds like a soft tide. If life needs time, peace, and cosmic gentleness, voids may be the gardens of the universe. Though metals form slowly in such isolation, the calm backdrop offers a stage for civilizations to thrive without constant cosmic violence. It is almost poetic to think that the emptiest places may be the safest, that silence may nurture complexity better than noise. But drifting deeper into this contemplation, one encounters the long future that awaits everything suspended within a void. A future where dark energy grows stronger, stretching the fabric of the cosmos faster than gravity can gather it. The universe is under no obligation to make sense to us, Steven Weinberg once reminded us. And nowhere is that more evident than in the fate of cosmic voids. In the ages to come, voids will expand more rapidly than the dense filaments around them, devouring those structures the way low tide slowly swallows footprints on a shore. It is not a hunger, but a cosmic inevitability. Dark energy pushing outward like a silent wind that never runs out of breath. Galaxies will drift apart until even the nearest neighbors slip over each other's horizons. vanishing from every sky. Communication between star systems will become impossible, not because civilization fails, but because space itself widens faster than light can travel. The cosmic microwave background, our oldest photograph of the universe, will stretch into invisibility. Its soft glow will become longer than radio waves, weaker than whispers. And eventually, it will dissolve completely into the darkness. Future astronomers, living trillions of years from now, will look into the sky and see nothing but their own isolated galaxy. Their universe will appear eternal, unchanging, lonely. And then comes the most heartbreaking question of all. If they cannot detect the cosmic microwave background, if they cannot see other galaxies, if expansion becomes invisible to them, will they ever guess that the universe was born in fire, in a Big Bang, in a moment where everything was closer than breath? Perhaps not. And perhaps that is the quiet tragedy of a universe ruled by dark energy. Still, I find a lesson inside this emptiness. A reminder that even the vastest voids do not erase meaning. They simply ask us to listen differently, to see differently, to understand that beauty is not the exclusive property of abundance. Sometimes, beauty grows in the slow drift of galaxies that never collide, in the patience of stars that burn quietly for eons, in the way empty space teaches us to value the fragile islands of light we call home. Ultimately, the void teaches humility. It reminds us that the universe is not built for our convenience, that the calmest places can hold the deepest mysteries, and that even in the most silent corners of existence, something extraordinary is still unfolding. As the Milky Way drifts through this cosmic desert, we become wanderers in a landscape that is expanding faster than our understanding. And yet, we continue searching, questioning, hoping. Because to be human is to reach for meaning, even when the universe grows quiet. To be alive is to measure the darkness, hoping to find our own reflection staring back. And so, in this vast and gentle emptiness, I find comfort in knowing that understanding is not the destination. It is the journey. A journey that continues, quietly, patiently. As long as we keep asking, keep listening, and keep wondering. After all, if even emptiness can cradle galaxies, then perhaps the void can cradle us too. As the final question of the video settles into the quiet space between thoughts, it lingers like a cold star, glowing alone on the edge of the cosmic web. Can we, as inhabitants of a vast, underdense void, truly understand the universe? Or are we listening to a cosmic symphony from a seat where half the notes are missing? The deeper we look, the more this question expands, stretching out like light traveling through a billion-year desert of near-nothingness. Perhaps our instruments, our measurements, even our intuitions, are shaped by the hollow space we were born into. Perhaps the universe is not lying to us so much as whispering from a distance, its voice softened, reshaped, blurred by the void itself. I often imagine what it would be like to stand inside a place where gravity barely holds on, where galaxies drift not as dancers in a crowded ballroom, but as solitary wanderers crossing a soundless ocean. When you live in such a place, every observation becomes a kind of meditation, a reaching outward, a listening for echoes that may never return. Yet it is from this quiet shore, this thinly populated corner of existence, that we attempt to describe the entire cosmos. And so the question becomes not only scientific, but human. Can beings shaped by emptiness understand fullness? Can eyes accustomed to darkness faithfully interpret the light? If our cosmic neighborhood is rare, if we truly occupy a region where the universe behaves differently, expanding faster, flowing outward, bending the Hubble constant itself, then our measurements might carry the imprint of this place like dust carried home from a foreign land. But that does not make them wrong. It only makes them ours. One might worry that our conclusions are flawed at the foundation, that every cosmic distance, every expansion rate, every age of a star might be tinted by our home void. But I think there is a gentler way to consider this. Science has always grown through correction, through refinement, through the quiet courage of admitting we saw only a fragment and reaching for a fuller picture. If we are shaped by the void, then the void becomes part of the truth. And perhaps, somewhere in another lonely patch of near-empty space, another civilization stares outward with the same questions. Would they see the same patterns we do? Or would their void distort their measurements in a slightly different way? Could they come to opposite conclusions about the age of the Raya, universe, the rate of expansion, the distribution of galaxies? If so, then the universe becomes a kind of cosmic prism, bending truth differently depending on where you stand. No single perspective contains the whole, yet each one is a fragment of the larger reality. This thought humbles me, and yet it comforts me too, because it means we are not wrong for seeing from where we are. We are simply incomplete. Understanding may not require escaping our void, but learning to see through it. When I reflect on this quieter truth, I find a kind of serenity. The void around us is not an enemy of knowledge, but a teacher, a reminder that all insight begins with limitation. Like monks in a silent cloister, we listen more deeply because the world around us is so still. Like travelers crossing a vast, empty plain, we learn to feel the subtle vibrations that others might miss. The cosmic void may distort the universe's voice, but it also amplifies our attention. And so I return to the question, not to answer it, but to breathe with it. Can we truly understand the universe from inside an emptiness 2 billion light-years wide? My personal belief is this: we understand the universe in the same way we understand ourselves, imperfectly, beautifully, and always in motion. The void does not mislead us. It merely asks us to look twice. And maybe the greatest lesson is this: meaning is not found only in what is present, but in what is missing. Our cosmic home is a reminder that emptiness is not nothingness. It is space to wonder, to measure, to dream. And perhaps that is why life emerged here at all, in the quiet margins of the universe. For in quiet places, curiosity grows. In lonely places, understanding becomes a form of devotion. And in the deepest emptiness, consciousness learns to light its own flame. So if you ever doubt our ability to read the universe correctly, remember this gentle truth. We are part of the cosmos trying to understand itself. Whether in a crowded cluster or a hollow void, every question we ask, every measurement we make, every story we tell, is another way the universe peers into its own reflection. And maybe, just maybe, that is enough.